Just outside of Los Angeles, there's a bright light, not just an anomaly on the side of the highway, but a beacon for those who want to make concentrated solar the next big renewable energy source in the United States. eSolar is a company that has made a modular solution to create fields of mirrors that basically heat a giant tea kettle in the sky and with very precise software can power thousands, some say millions of homes in the U.S. I talked to Rob Rogan, Senior Vice President at the company, to find out how this system works and what makes eSolar's approach unique.
Just looking across this incredible field, these aren't photovoltaic panels.
Nope, everything we build is just steel and glass. So we essentially put all these mirrors on the ground, reflect sunlight, and focus it like a magnifying glass. And at the top of these towers where the sunlight's focused, we boil a lot of water and make a lot of steam.
So you have to wear sunglasses to look up there. It is just a beacon of explosive brightness. What's happening up there?
Well, essentially we're just using a lot of heat from the sun to boil water, and once we have that high pressure steam, we route that back to a steam turbine. It's the same type of steam turbine that's used in a fossil fuel facility. The only difference here is we don't burn anything, we just use the sun to create the steam.
Huh. So why not use photovoltaic panels? Why use mirrors?
Well, our technology is built to be deployed at a massive scale. So as you can see, there's thousands and thousands of mirrors here, but as compared to photovoltaic technology, it's all commodities. So we're using a more cost-effective method of capturing the sun for enormous projects. So this is a technology that's not intended to go on your rooftop. It's intended to be power plants that power the grid and are a replacement for fossil fuel technologies on a massive scale.
Does this compete with photovoltaic?
It does. I think there's multiple solutions to providing solar energy. Photovoltaic is well suited for many situations, and solar thermal is better suited for some situations. Generally speaking, the larger the power plant you want to build, the more attractive solar thermal technology looks from a cost perspective.
How cost effective is this concentrated solar facility?
Well, our goal at eSolar is to be able to compete with fossil fuels directly without subsidies. And we're not there yet, but this plan is the first step in our company's progress to essentially being able to replace fossil fuel-fired facilities in most markets in the world.
So you're talking cheaper than coal?
Eventually, yes.
What's it going to take to get there?
It's going to take deploying it on a large scale. Fossil fuel technologies have been around for over 100 years. Mankind has been burning everything that we can get our hands on to produce energy for the past millennia. And right now, this is a technology that's just arrived on the world stage, and the more we build, the cheaper it gets, and the more cost-effective it becomes.
How far off the mark is it right now, just in this? I know you're in small scale, but I mean, what kind of distance are we talking to profitability?
Well, right now this technology is sellable in the United States. We have almost 500 megawatts of this technology under contract in the U.S. to be built in the next 3 to 4 years. We also have 1,000 megawatts that are going to be deployed in India with our Indian partner. And so it's not that it's out of market right now, it's extremely competitive as a renewable technology, and the market has already started to pick up on that and purchase it in large quantities.
How much land would it take to make this the biggest source of energy in the U.S.?
Well, our technology in particular takes about 4 acres of land to produce 1 megawatt of electricity. Which is extremely compact for a solar technology. As far as we know, it's the most compact land use of any of the solar technologies. So to power the entire world with this type of technology takes about 90 miles by 90 miles of land. That would produce enough energy to power the entire planet.
So what state is that? We're talking like...
It's about the size of Delaware.
Delaware. I've never thought of Delaware that way. I have a new respect for Delaware. I think, the big question here is, is this the best solution?
Well, we think it's the best, but we're a little biased. The reality is that, renewable technologies, you need a menu of choices to choose from. Our technology doesn't work well in places where you don't have lots of cloudless sunshine a year. We need sunlight that casts a shadow for our plants to work. So our technology doesn't work on the east coast of the United States. Other solar technologies work, geothermal, wind technologies work there. So you need a lot of solutions to fit into all the different areas where all the different resources are. Our technology is extremely well suited for the southwest United States, the Middle East, Australia, lots of places around the world.
How long are the ramp-up times to get a facility like this online compared to something like nuclear?
This facility where we're standing was built from groundbreaking to delivering electricity to the grid in under 1 year. So for our typical power plant designs are 46 megawatts, which instead of the 2 towers you see here are 16 of these towers linked together. And those facilities take on the order of 13 to 14 months to bring online from groundbreaking. So it's extremely fast to build.
What's the downside of this type of energy production?
Well, all solar energy right now is a little handicapped because if the sun's not shining, it's not producing electricity. Solar thermal in particular does have the ability to store heat and then use that heat to deliver energy when the sun isn't shining. And that's a path that I think all the solar thermal technologies are eventually headed to.
Can you walk me through a little bit of what's actually happening here, from panel to that thing to turbine?
Sure. So what you see behind you here, this is a field of approximately 6,000 mirrors. On the other side of the tower, we have another 6,000 mirrors. Each of these mirrors is independently adjusting over the course of the day so that it's constantly reflecting sunlight to that single point at the top of the tower. If you look carefully at the top of the tower, you can see some mirrors coming on and off as we're modulating the amount of heat up there. So every single mirror here is reflecting one sun. So up at the top of the tower, we have over 4,000 suns of heat going to a single point. All of that heat is then used to boil water. We feed water up to the top of the tower. It gets turned into superheated steam, and then steam is returned down in these big pipes that you see behind me. We collect the steam from this tower and from the tower on the other side and route it all back to the centralized power block, which is behind us.
And so there a turbine spins the same way a coal-fired plant would spin a turbine in a fossil fuel plant.
Absolutely.
So there's nothing different when I flip the switch.
Well, that's part of the trick. The trick is making all of this seem exactly like a coal-fired burner to a power plant operator, and that's why eSolar's gone through the trouble of building a full power plant. Just producing the steam isn't quite the whole story. You need to understand how to operate it on a daily basis so that it's a reliable power plant.
What's that noise I'm hearing? It's like a subtle hum.
That little hum is actually the mirrors, the motors in the mirrors actually turning them slightly. Each of the mirrors moves about 2 or 3 times a minute. Actually, if you look carefully, you can see this one right behind us moving right now. And so part of eSolar's technology is really the software that we've developed to control all of these mirrors. It's not so simple as just reflecting the sunlight up to the tower. It's a question of the 6,000 mirrors here, how many do I need to point and what angles do they need to point at any time in the day so that the heat at the top of the tower is always constant. Constant heat is something a turbine likes. If the steam and the heat vary dramatically, then that causes problems for operating the power plant. And so this field behind us is constantly micro-tuning and adjusting, essentially flexing the focus to change the amount of heat that we're seeing up there.
You know, as I was driving down the freeway, I could see this in the distance, and it looked like lights for a football field. It was so bright, even in full daylight. It was amazing. But it's not a huge footprint visually in terms of, you know, changing the landscape. What are the complaints you've had around that?
Well, we haven't had any complaints. We're building here in Lancaster, and on the hills behind us are thousands of megawatts of wind turbine towers. A wind turbine tower today is much, much taller than the tower you see behind you. So these towers, we designed them to be 200 feet at the top. That's low enough that it's actually about the same height as the average transmission line tower. So visually speaking, it's not a whole lot of impact to the landscape around it. Additionally, we're able to use wind turbine towers and take advantage of that supply chain to help keep our costs down.
Does that thing ever get so hot you worry about it blowing up?
No, not really. We have...
No, not really.
Yeah, well, I mean, yes, of course we worry about it, but there's a lot of safety trips built in. So, you know, for example, we're constantly measuring the temperature up there because we want to know what the temperature of the steam is that we're putting into the turbine. And that's what all the mirrors are doing is, you know, coming on and off point, we call it. On point being focused, off point being slightly off focus to balance it out. But even if the whole power plant, you know, if you cut the wires coming into the power plant that are providing, you know, power to the mirrors, there's enough backup power on site to move all of the mirrors off of the receiver very, very quickly. It only takes about 30 seconds to get all of the heat off of the receiver.
And, I mean, worst case, we're talking about hot water, right?
Mm-hmm.
Okay.
When we come back, the software and robots that control and clean all these mirrors. Plus, recycled 1930s era turbines that turn this giant tea kettle into electricity for your home. This episode of TWiT's Top 25 Green Tech Innovators is brought to you by the Eco-Imagination Challenge from GE. GE and its partners are awarding $200 million to ideas that help build the next generation power grid for the 21st century. For more information and to view and comment on ideas, go to ecoimagination.com/challenge.
You know, compared to some of the other options for energy creation, this seems like an environmentalist's dream. It doesn't smell, it's not loud, it doesn't seem to be having any impact on any kind of wildlife. What's the feedback you've gotten?
We've had great feedback from the environmental community. Because we have such a small footprint, again, 4 acres to produce about 1 megawatt of electricity, and we're building these plants in small blocks. So one of the advantages of eSolar is that we can be cost effective at 46 megawatts of size. Typical solar thermal technology requires 250 megawatts or more at a single location. These are massive projects. eSolar tries to site our projects on abandoned farmland that's already been previously disturbed. We site near existing water resources, so we're trying not to have too much of a local impact on water. And we can build them very quickly. In addition to that, once we've built the plant, we need a staff of about 20 people to operate it. And so we are creating local jobs during construction, permanent jobs, and we're trying to do it with a minimal impact on the environment.
You guys go through a lot of Windex?
Actually, we don't use people. We have actually little cleaning robots we use. So this
Cool.
row of mirrors at night opens up, and there's a little robot that drives down and sprays off the mirrors on either side.
Oh,
So
that's cool.
once in a while, we do have to contact clean them, but we try not to have guys out here with Windex. That's pretty expensive.
How is Wall Street buying into this type of solution to the new energy economy problem that we're trying to sort of get moving here in the U.S.? I mean, I guess the better way to phrase that question is, are you seeing Wall Street investors getting excited about this technology as being a part of the new energy economy?
Absolutely. I mean, right now, eSolar, just as a company by itself, has raised over $170 million in capital, not just from venture investors, but also from large energy companies such as NRG Energy, who's buying the power plants that we've developed. I think in the United States right now, just in California, there is over 5,000 megawatts of solar thermal projects under contract with the large utilities. And so we're in the very early stages of a massive upswing in solar thermal deployments.
So what do you need from the government for this to really become profitable?
Well, in the United States right now, there's a 30% investment tax credit for solar projects, as well as the availability of Department of Energy loan guarantees. All of those things are helping solar thermal get built. And it brings the price of the solar thermal project into a range that the utilities are willing to buy it at. In California in particular, there's a 33% requirement that utilities must buy 33% of their energy from renewable sources. And so while not all renewable energy directly competes with coal, which is or nuclear, the cheapest forms of energy, they do compete amongst themselves to fill out that 33% requirement. And eSolar's had some success winning contracts in that space.
The basis of so much energy production is heating up water. And this is just a simple idea that you've taken big time. Who came up with this?
Well, solar thermal technology was originally invented in the United States, and the first projects were built over 30 years ago. The issue with solar thermal has never been the science behind it. It's been the cost issue. How do I build a project in a very cost-effective way? And so the approach that eSolar took was to, instead of building things in a big infrastructure-like fashion or an aerospace mentality, was to use small, mass-manufactured components that you can lay down on the ground simply. All of the things you see here in the mirror field can be built by 2 people using 4 socket wrenches and 1 Phillips head screwdriver. We don't use cranes, we don't pour concrete. None of this is even penetrating the ground. It actually just all sits on the surface. The trick to that is that now you have to control all of these mirrors to a high degree of precision. And eSolar's software application is what has allowed us to control the mirrors. So we're basically taking out all of the steel and all of the glass to a minimal extent and then using software to make up the difference. 20 years ago, the software and computing power to do what we do here didn't exist. The only commodity that always gets cheaper is computing power, and that's essentially what we've leveraged here to make this cost effective.
So basically you've turned this into some sort of a Lego kit that somebody could just plop down, set up, and run with a computer, and that's what you're selling.
Absolutely. In fact, to build all of these 6,000 mirrors on this side of the field takes only about 1 week with a 36-man crew of people. It's extremely fast to deploy and thus very cost-effective to build.
I want to take a break from our Green Tech Innovators series and tell you about our sponsor, Audible.com. Now, if you don't know about Audible, they are the provider of over 75,000 titles of audiobooks that you can download. Listen to them on your computer, listen to them on your iPod. And I am a huge fan of audiobooks. I listen to them in the car, listen to them when I'm out and about. But here's an idea that I'm trying with my mom. She's committed to a new exercise program, and she says one of the things that really helps her to stay out walking is to listen to an audiobook while she's walking. So I just downloaded The Namesake by Jhumpa Lahiri, a great novel, put it on Mom's iPod, and she is walking longer, she says. She's out enjoying nature and doesn't seem to get as tired. Somehow keeping the brain busy with a great story keeps her feet moving. So this is a book that I downloaded easily. It's very easy to do from audible.com, and you can do it too. Try out one free book. Here's how you do it. You go to audiblepodcast.com/greentech, and you can get a free audiobook. Try it out. Again, it's audiblepodcast.com/greentech, and we thank them for their sponsorship of this show. To truly understand how this field of mirrors operates, you need to see them move, and that mandates a unique perspective.
So this is sort of the trigonometry of the deal, right? We've got sun, mirror, tower.
Mm-hmm. Yeah, so right now we're standing where the sun is standing, more or less. And the trick is to position this mirror so that the sun comes in, hits the mirror, and then reflects up into the tower behind us. And the trick is we've got to move this mirror over the course of the day so that it's always reflecting the sunlight into the tower. And we do that with 12,000 mirrors simultaneously to hit each of our towers.
Oh, it just moved.
There it goes.
Whoa. Cool. So that's a pretty big movement.
Well, actually, what we're watching right here is this mirror is now being taken off the point on the receiver, meaning that the computer system has decided that of all the 6,000 mirrors out here, it's going to use a different set of mirrors to get that light onto the receiver.
Because we're in the front row, so the sun's moving away from us first, probably.
That could be it, or it could be that, whatever the computer system decides, it could be choosing the mirror behind it or, some other combination of mirrors. The trick is we don't want to overheat it, but we want to keep it really, really hot.
Yeah, I bet if you worked out here a lot, you'd go through a ton of sunscreen.
Yeah, the guys in the summer when they're out here are normally dressed, head to toe covered. It gets up to be 115 degrees out here in the summer, and it's brutal sun. But that's why we build a power plant here.
Right, makes sense. Oh, here it is moving again. Wow.
It's coming back now, see?
Oh, now it's coming back just that fast?
Mm-hmm.
So that was just off for a minute.
Mm-hmm.
That's pretty responsive software.
It's extremely responsive, and that's the trick, right, is that we have to be able to fine-tune this system. Because the sun moves, we can't keep everything in the same place. And so there's this very, very fine level of control that we need to produce all of this power economically. Doing it by brute force it turns out very expensive.
So what's new here is the computer technology that allows you to fine-tune sort of the efficiency and optimizing this from a cost-effective perspective.
That's right. I mean, basically the accuracy with which we need to point this mirror in front of us is equivalent to taking a BB pellet and throwing it in a drinking straw from about 10 feet away. We do that 12,000 times every minute, every day of the year. That's the level of computational power that we need to solve this problem.
From cutting-edge software and mirrors heating water to the truly old school, engineering that turns steam into the energy that powers our homes. To show how their mirror technology could work, eSolar has tied it all together with a turbine from way back when.
What are we looking at?
This is the steam turbine and the generator. So this is where we take all the steam that was created out there, all gets piped in and then run through this box you see in front of you.
This is what I would expect, a big, heavy piece of machinery to look like, but it's not real space age. This looks a little retro.
This is actually a 1948 GE steam turbine that we retrofitted to build this project. So we wanted to build it quickly, demonstrate the technology works, and figure out how to integrate the solar part with the old world part.
That's probably a good thing. If people are going to go off of coal, they have some parts they could recycle?
In a lot of places, there are parts where you can integrate the steam from the solar field and use a lot of existing equipment. So for our normal power plants, we normally recommend people buy new turbines to use them, as then they're warranted and they'll last for a lot longer lifetime. But this one's done us great.
Cool. Looks like an igloo.
Well, it's got the casing on. You know, when it's got the casing off and the guts are open, it's a little more intimidating looking. So basically, steam comes in, generator's on the far end there, okay. And then the steam comes out, goes down into the floor below us, gets condensed back into water, and then sent back out to the towers to be heated up again, and then that loop just goes all day long.
So in here, we just got spin, 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 spin.
That's it.
Spin cycle equals power.
That's correct.
Cool.
So as municipalities try to tie together old technology and the latest in renewable power, eSolar certainly has something to show them. Hey, thanks for watching. If you have any comments on the show or anything for the TWiT Network's Top 25 Green Tech Innovators series, email us, greentechtoday@twit.tv.